Okay. We're going to do three-dimensional shapes, which is why I have my shapes. I have one back there. We're going to do a cylinder and a cone. And this was the smallest cone I could find, which is huge. This is an oblique cone. Have you ever seen ice cream cones in this shape? I have.
What are they called?
Waffle cones. This is oblique. Yes, it's AV3 Lesson 4. Okay? Zach? TJ, question? So I've seen ice cream cones like this. And then, of course, the challenge is, because they always wrap them with paper, is to get the right shape for the paper and to minimize the loss of paper when they cut out the patterns. So if you go to 31 Flavors, Baskin Robbins, they have the strangest, you pull off the little papers around, they're a very strange shape, but they put it all on a big piece of paper and they, cut them out. They want as little waste as possible. So yes, geometry is used every day. And if you go and look at the new Vikings stadium, go look at pictures, Zach, go look at the pictures of the new Vikings stadium, it's all geometry.
Why do they make them like this?
Just to be different. That's it, that's the only reason.
You look there and
No, when you
Okay.
make them in a circle and then when you roll them up, that's the shape they go.
Maybe. Okay, so we're going to do cylinders and cones. We're going to do this kind of a cone. Now, here's the thing, is the altitude of the cone goes from the vertex to the center of that base of the circle. And later on, I think we'll come back to this. It'll probably be AV4, where you'll be given the altitude, and you're going to have to find this blue line here, which is called the slant height. So we'll be doing some right triangle problems, which will make things harder. But anyway, here we go. We're going to start with a cylinder. And we want the surface area. Okay, Zach? I want the surface area. And that's the formula. We'll give you the formula. You have to use it, but it's nice to know where it comes from. I'm not sure this is working, but okay, let's look at the picture because you're going to have more complicated problems than this. This one's really hard to figure out the surface area. I don't know how to do that easily. Okay.
You don't know how to do it?
Not on an oblique cone. I know how to do it on a regular cone. Here, I want to make this can, if you want to think of it that way, I need the two ends. So those are two circles, which is what this is right here. That's two circles. And then on the outside, this is the label. And yes, my paper's bigger than the actual can, but if we think of the Campbell's soup label, that's what it would look like. And when you pull it off, what shape is that label, TJ? Oh, it's a rectangle. And so how do you find the area of the rectangle? Okay, Zach. We have...
You find the area of both circles, of both faces, and then
And we're going to undo this. We're going to lay it out flat. And so it's going to look like this. So what's this called? Zach, I think you need to sit over by Ethan. Yes. No, don't argue. I need this length right here. Right? Which is what? Shh. No, over there. Okay. I need this length right here, which is the what? It's the height of the cylinder. Now, you don't have to know where the formulas come from, but during the lesson, you're going to say, hey, where'd that come from? I'm explaining it right now where it comes from. Okay? So this is the height. This is H. And this length, which is the base, what is that?
That's the video.
Okay, but I want the length of this circle, the length of this piece of paper. What is that, though?
That's
The perimeter of the circle starts with, it's the circumference, isn't it?
I understand.
That's okay, but it is, right? It is a circle. It's the circumference of the circle. So this is 2 pi r. That's what this is. That's the circumference, and that's the height.
To the equation.
Yes, but it would be nice to understand it. So let's do this problem. I think I forgot to do it the first hour. So it's 2 pi. TJ, what's the radius?
4.
So it's 4 squared plus, Cole, what's the radius?
4.
4, what's the height?
12.
And that's it. Yeah, but the first two are easy like this in your homework, but the second two are much harder. So you multiply that out. Now, you guys realize you can multiply all that together. 4 squared is 16. 16 times 2 is 32 pi plus. And it doesn't matter how you multiply this out. I would go 4 times 2, which is 8, and 8 times 12, because I know that one is 96. No, you're just going to use the formula. Now, some of you struggle with adding that. You can add those. But the question comes into, why can you add them? Why do you... That's correct, up to a point. Why can we add like terms? Okay, here's the reason why. This x was distributed. It has a common factor of x. If I factor out x, I'm left with 32 plus 96. And guess what? I know how to do that. That's just plain old arithmetic. And that's why you can add the x's together. You add the coefficients. Because they are like terms, not enough. It's because we factor out, we factor out an x. Yeah, I just hit a button here. Sorry. Unfortunately. So all we have to do is add those numbers in front. Oh, I got that to work. Good. Pardon? And so this is 128x. Why can I add these? Because I can factor out a pi. It's 32 plus 96. So it's 128 pi. Some of you struggled with leaving your answers in pi. Actually did fairly well on your quiz. Okay, guys? So you want to leave your answers in pi because that's the way the test is going to be written.
Sick dog.
Okay, now let's do a cone. Cones are a little harder. I'm not going to explain where the formula comes from, although we have part of it. Okay, Curran? I want the area to go around the outside of the cone, and I want the area of the base, which is a circle. That's pi r squared. So that's what this is. That's the base. I have it on the other slide. Just add it up. You don't even have to do a carry. Okay. Pi RL is the area of the outside of this. Now, I drew a line on here. This, if I go from the vertex to the center, is the altitude of the cone, Zach. And this line here is called the slant height. We've seen slant heights before. So that's pi RL. So let's do this problem. So the surface area, Zach, what's the radius? 3. What's the slant height? Sydney? 7 plus pi r squared. R is 3. Okay, so that's 21 pi. Order doesn't matter. In which order which I multiply doesn't matter. Plus 9 pi. And what's the answer, TJ?
9 pi plus 21 pi is
35. It's right up there. So you've got 2 equations. And I think I only have one problem left. That's it, except we're going to do a hard problem. The very last problem is like the last 2 problems. And what we're going to do, the formula isn't hard, and it's not hard to use. The problem is you have to figure out what you're going to add up. Are we ready to go on to the last one? It's a matter of going slow and doing a lot of bookkeeping. This is an annulus. Okay, I'm going to draw this because what's happened is we've taken the inside out. I don't know if my picture here helps at all.
So you have to use a big pi r.
R squared. Oh yeah, that looks pretty good. And actually, your pop can is the same thing. There's a thickness, not very thick actually, but there's volume there. So I want to paint the outside, the inside, and the two bases. But the bases are, it's not a full circle. Like Cole was saying, it's this part right in here. It's the annulus. I prefer washer because that's what we call it in Calc. Washer. You've seen washers. No, like a washer when you build something. Those little discs. Okay, Curran? So here's the plan. We have two of these. We have two bases. And then we have what? We have the outside of the can. So we have the lateral area of the outside. Well, I want to get everything painted, and I have the lateral area of the inside. So let's do the bases.
So this is what you do. You do
Yes.
2 pi 9 squared plus.
Well, let's get the plan.
No, and then you subtract the smaller.
Right. It's pi big R squared minus pi little r squared. Should we do that right away?
Yeah.
Because we've got our plan here. The problem, this is the hard part. Figuring out all the pieces you have to add up. Using the formula is not hard. This is pi. What's the big radius? 9. Pi, and the little radius is? So that's 81 pi minus 25 pi, which gives you 56 pi. Good. Okay, and we're going to have two of those, right? So how much is that going to be? So all the bases add up, because I got two of those. So it's 2 times 56 pi, 112 pi. Okay, I'm going to circle it so I don't lose it. Because I'll lose it otherwise. Okay. Now let's do the lateral area of the outside. Now you have to use that formula. It's the lateral area of a cylinder. And the lateral area of a cylinder is the circumference of a circle, 2 pi r, and it's times the height. So for the outside one, the outside lateral area, it's going to be 2 pi capital R times the height. So I want the big cylinder, so I'm doing the outside here. Okay, so it's going to be 2 pi times the big radius, which is 2 pi, what's the big radius? 9. And then I have times the height, which is 15. And Cole's going to tell me what that multiplies to give me to. Yes? Because we had two of these bases. We had this one, and we had this one. I want to do 18 times 15.
270.
You can do 9 times 15 and double it. I don't care. 18 times 15 is what? 200 and...
Can I give you an example of an R4?
No, this is an R3. The R4s I gave you on that pink sheet. I think it was pink. Yes, you'll have to figure out the pieces. So the part that you unwrap. What am I going to do with that?
Sorry, it's not 275, it's 270.
Is it 270?
Yeah, I said it up twice.
Oh, okay, it's 270 pi. Don't forget the pi. Okay, now you got to do the inside cylinder.
150.
Well, how'd you get that?
You do 2 pi.
So inside, wait a minute,
2 pi
you're ahead of me.
r, or small r,
2 pi little rh.
which is 2 pi 5.
Well, this is nothing compared to the real world in terms of engineering and things. Times, this is just the beginning. And I can do 2 times 5, which is 10. And 10 times 15 is 150 pi. What are we going to do with all those?
So it's 1.
Add them.
No, we're not going to subtract. We're painting it all.
Large.
I want to paint the inside of the cylinder. Because that's what it said. I want the total surface area. So we're going to add them all up. So I got 112 pi Somebody's going to add it for me. Plus 270 pi plus 150.
532.
You see, right? And that's how we leave our answer in exact form.
What did you say it was?
532.
Yeah, that's right.
And that's what engineers do. You'll do a calculation, he'll do a calculation. You'll talk about if you don't match. Hopefully you're going to match, but and hopefully you're both doing it right. What? No. Okay. Well, they're posted. I had them all done. I think I left them in the other room, but I'm not sure. Yes. Lateral area. Good question. Always ask.
Did you give us our extra point because we didn't ask a question?
Yes.
Yeah, we didn't ask a question.
Yes, they all got added in. I know where they are. I'll have to run and get them.
You asked a question.
We didn't.
No, we didn't ask a question about like how to do it.
I'm gonna go get. No. No. Just go throw it. No.
Yes.